One of the skills that you need to be able to do is to write a chemical formula from the name. It's really important that you get used to these ions that are in these ionic compounds, so because it comes in multiple times during second semester. So here we go. So whenever you have the name of something, what you're going to recognize, or what you should recognize, is that you have a first name and a last name. So I have magnesium as my first name, and then my last name is fluoride for this compound. So I split it in half. I'm going to focus on each thing separately. So what I need to do is, I think it's best if you start looking at for a polyatomic ion first. So I think about these words, magnesium and fluoride. I go over to my polyatomic ion table, and I have to look to see if I have a polyatomic ion. I scan through and I do not have a polyatomic ion. So then I know that everything I'm going to need, I'm going to find on the periodic table. So what I need to look for is the symbol and the charge. So let's look back and see what we're looking for. We're looking for magnesium first. So that first name for the ionic compounds are going to be somewhere on the left side here. So I scan through and I find magnesium. So the symbol is Mg and 2+. So I'm going to write that down in right above the word in my little box here. And then I'm looking for fluoride. Now remember, when we use the periodic table, or when we have an element in these names, we've taken the ending and changed it from the name of the element to IDE. So usually, a lot of times it's going to be fluorine, or you just change it to INE, but you're going to need to look for something that looks similar to that. So we go back to our periodic table, and we see fluorine right here, which is the fluoride. So I've got fluorine, and then the group it's in is a group that has a charge of -1. So now I'm going to write that down. So I have F -1. Okay, so those are the two ions that I have. Now, all ionic compounds need to have charges balanced out. I need to have the same number of positives as I have negatives. So looking at this, I don't have the same number. I have 2 positives and 1 negative. So that means in order to get these to balance out, I am going to need another negative charge. So now when I look at my charges, I know that the positive and the negatives balance out. So this is telling me that I need 1 magnesium and 2 fluorine. So the way I write that is to say MgF2. So this 2 is telling me that I need 2 of them. All right, the other method to do it is that crisscross method. So I've got Mg, 2 plus, F1 minus. I get rid of I kind of ignore the charges, and I take the 2 and it becomes a subscript for the fluorine, and the 1 becomes the subscript for the magnesium. All right, let's go on to the next example. All right, our next example is aluminum sulfide. All right, same thing. I'm going to look for aluminum and sulfide on my list of polyatomic ions. I've got one that kind of looks like it. I've got sulfate, but sulfate is not sulfide. So it's really important that you're looking for the exact name on this, because these polyatomic ions never change the spelling. Like, that is exactly what it's going to be. And so since that's not what I'm looking for, now I'm going to look at the periodic table. All right, so again, the 2 things I'm looking for, aluminum and sulfide. So I start looking for aluminum, and I see I've got aluminum up here, element number 13. It is Al and has a 3+ charge. So I'm going to write that down. And then sulfide, looking back at the periodic table, sulfide is sulfur, element number 16, and so that's a -2. All right, so those are the ions that make up this compound. Next thing we're going to need is to figure out what the formula is. And again, I'm always trying to balance out my positives and my negatives. So a couple ways to do this. One way to do it is to take these numbers, the 3 and the 2, and just crisscross them. So this 3 is going to end up being the subscript for the S, and then the 2 subscript for the Al. So I'd have Al2S3. All right, here's the reason it works. So if I just start with one of each, All right, those don't balance. I have 3 positives and 2 negatives. So I need more negatives. Well, the only thing I have is the S for the negatives, and they come in twos. I can't just say, oh, I just need an S minus 1. That doesn't exist. So right now, it still doesn't balance. I now have 4 negatives and 3 positives, so I need more positives. So I add another aluminum 3 plus. So now I have 6 positives, but only 4 negatives. So I add another sulfur. Now my positives and negatives are going to balance each other out. Now when I look at them, I have 6 positives and I have 6 negatives. That's what I need in order to make sure this compound is correct. And you'll see I have 1, 2 aluminums. That's where I get that 2 from. And I have 1, 2, 3 sulfurs. That's where I get that 3 from. Okay, let's try the next one. Okay, copper 2 oxide. Again, I've split it into the first name and the last name. And now we've got something new to deal with. We've got this Roman numeral. Which tells us the Roman numeral is always going to be the charge. The Roman numeral is not how many coppers I have. It is the charge. So this is copper, and looking at your periodic table, copper is Cu. And because it says Roman numeral 2, it is Cu2 plus. All right, if the name of the compound was copper 1, that would be Cu1 plus. Since copper can have more than one charge, we have to communicate what that charge is. All right, so I have copper 2 plus, and then I have oxide. Again, I'm going to look at the polyatomic ion list to see if this is a polyatomic ion. As I scan through, I don't see anything that is exactly oxide. I see hydroxide, but it needs to be exactly one of these. It can't be kind of spelled like it. It needs to be exactly this. So then I go back to my periodic table. I'm looking for oxide, which is oxygen. So my second part of this is O2 minus. All right, now I need to take those and figure out a ratio that allows them to have the same number of positives and negatives. Well, I've got a plus 2 and a minus 2, so I actually only need CuO. Again, you could look at it as crisscrossing the charges. And so I take the 2 here and then put it down there, the 2 there, and I would have Cu2O. But you have to remember that whenever we're writing ionic compounds, we want to write them in the lowest, we have to reduce them. And so that's why it becomes CuO. Okay, all right, let's go on to another one. All right, calcium hydroxide. Again, I did the same thing. I separated, I'm looking for calcium, I'm looking for hydroxide. So I'm going to start with my polyatomic ion list. All right, calcium, I've got a couple things to start with C, but none of them are calcium. And now I'm looking for hydroxide. Hey, I do have hydroxide on here in that lower right. So hydroxide is OH minus. So I'm going to write that in first. So OH minus. Again, polyatomic ions are kind of like Zendaya, Madonna, Cher, Beyonce. They're so ubiquitous that we only need one name to describe them. We don't need to talk about both the oxygen and the hydrogen. They have one name, hydroxide. All right, then we have calcium. So now I have to look at, it's not on my list of polyatomic ions. So I look at my periodic table. And again, since the first name of the ionic compound, I'm looking on the left. So I see calcium there, element number 20. So it has a charge of plus 2. So I have Ca2 plus, or plus 2. Again, we don't care how you write it. All right, now I'm looking at these and they don't have the same charges. I've got one that's a plus 2 and one that's a minus 1. Again, if they're like plus 2 and minus 2, real straightforward, I only need one of each. Now I need to figure out the ratio that allow them to have the same charge. So I would need 1 calcium and I need 2 hydroxides to balance out my 1 calcium. Again, because I'm always looking at this 2 plus needs to balance out however many negatives I have. And in this case, I'm going to need 2 hydroxides. So when I write the formula, I need to communicate that I have 1 calcium. And then the hydroxide, whenever you have more than 1 for the polyatomic ions, you have to put it in parentheses. Because what I'm trying to communicate is that I have 1 calcium and 2 hydroxides. I do not have 1 calcium, 1 oxygen, and 2 hydrogens. This does not reflect what makes up my compound. this one does. So again, that parentheses, the 2 has to be outside that parentheses. All right, next one. All right, I'm going to, if you want to practice this one, go ahead, stop the video, and then when you pick the video up again, I'll start going through it. All right, so I've got 2 things going on here. I've got manganese 3, which that tells me that, again, the 3 is going to be the charge. I just have to figure out the formula of manganese. And manganese and magnesium are spelled similarly, so be careful. Manganese is Mn, and then that Roman numeral 3, remember, tells us that it's a 3 plus charge. And then phosphate, that is on your polyatomic ion table. Again, check your polyatomic ion table first to see if you have any of these on there. So phosphate is PO4, 3 minus. All right, so now I look at these and I have, they're both 3s, 3 plus and 3 minus, which means they balance each other out. I have the same number of positives as I have negatives. So I end up with my formula, MnPO4. Okay, because remember this PO4, it's this whole thing that is the -1. Sometimes students get confused and they're like, oh, that means this. That means there are 4 of these. No, because the 4 is on the inside, the 4 is glued to the oxygen. It's not that I have 4 POs. I have 1 P and 4 oxygens. So I have MnPO4. All right, and I think this might be our last one. Nope, got a couple more to do. Oh, hey, I got a bunch of examples for you. Okay, so same thing. If you stop the video, practice it yourself, and then I'll go through how to do it. All right, so for this one, zinc is my first name of it, Zn, and this is one of the charges that we're going to have on that periodic table for you. Zinc is going to be a +2, even though it's in those transition metals, we always find it in the form of +2. All right, and then nitride is a common one students make mistakes on because they're like nit something, and then they look at their polyatomic ion list, they're like, oh, hey, I bet that's nitrate. No. If it's a polyatomic ion, it's spelled exactly the way it is on the polyatomic ion. We never change the spelling of those names. So this one is nitride, which means it's on the periodic table because it's not nitrate. Nitride is N-3. All right, so then I'm looking at these. The formula I'm going to end up with is Zn3, N2. Again, I need to have the same number of positives as negatives. All right, another one just to keep the confidence going. So go ahead and try this one. And again, stop the video and I'll go through the answer when you come back. All right, so looking at this one, this is a polyatomic ion. So nitrate is what's on the polyatomic ion list. So nitrate, we're saying that, hey, this is NO3 with a -1 charge. All right, so then I've got sodium, which I find on the periodic table, Na+. So now these have they're both 1s, a +1 and a -1. So I have NaNO3 as my chemical formula. All right, and then last one right here. So again, same thing, stop the video and I'll go through it when you get back. Okay, so gold 3, that's telling me that this Au is gold. The 3 is telling me that it's a +3. All right, and then oxide, that's oxygen. So I have O2-. All right, so now I look at those, and again, I need to think about it as crisscrossing the numbers, think about it as what ratio gives you the same number of charges. So I have Au to O3 as I'm doing that one. All right, so again, if you were struggling with the writing the formulas, you might want to go back and watch the video or find a different video on YouTube that kind of helps you out because it's a universal thing that everybody, anyone who makes a video should be kind of going through the same way of doing it. Hope that helps.